Contingency tables are one way to display data so that we can make some inferences from it a little bit more visually than just listing out. So we have a table to look at. In this particular table, we have it organized by gender and whether or not they are left and right-handed. So there were 100 people, our S, our sample size is S. So that is our whole group. So we are going to look at some of these issues here. And M, events, is that the subject is male. F is the subject is female. R is right-handed, and L is left-handed. So we're going to have these different probabilities here to compute. And on the next click, I actually have many of them solved, but I want to talk about it before we show the answers. So let me get a pen here and just to keep track of where we are. So the probability of someone being male. Well, how many males are there? Well, there aren't just 43 males, right? There are 43 plus 9. So when we talk about the probability of someone out of this sample being a male, we have to actually have 52 out of 100, out of the total number. So hopefully that makes it a little bit clear. Let's jump down to one of these other ones, and I'm going to let you kind of work through these at your leisure. Maybe one of the ones that is just a little bit crazier. Let's look at this. The probability of right-handed happening after we've already decided that the pool we're drawing from is the males. So we would look at all of the males, which we already discussed, is 52. So instead of 100 being our number, we're going to be looking at 52 that we're out of. And out of those, how many are right-handed? And we have right there are 43. So it would be 43 out of that 52. I hope that makes sense. But on the next slide, I do have some answers to these. So if you want to go back and forth, you know, as we continue, I will move my face so that you can actually see the answers. And there's the rest of them. I think this one, well, that wasn't very long enough, was it? Anyway, hopefully you can take a moment to pause the ones that you need to pause. On G, I just added that that does equal 100. We are talking about on G, the probability of being male or female. Well, since that all of the individuals fell into one or the other of those classifications, we can say it is 100 out of 100. We didn't include any other groups in this. It was a random sample and organized by gender. There were only 2 genders in this. So if we ask for both of those, that is 100 out of 100, which is going to be the same thing as 1. So refer back to this as you work through this table 3.1 in your book. Mutually exclusive and independent. Let me see if I can raise my things just a little bit. I can't. I can slide it over and see that part, or I can see that part. So I'm going to leave it right in the middle. What it is 3.2, independent and mutually exclusive events. These are not the same thing. Many people use the terms interchangeably. They are not. Mutually exclusive means that I am in one group, I cannot be in another group. If I am right-handed, I cannot also be left-handed. So those are mutually exclusive events as we're looking at samples. Independent events mean that I can do one thing and I can do another, and they have no relation to each other, like flipping a coin and rolling a die. Those 2 events don't have anything in common, but I can sure calculate the probabilities of flipping a head and rolling a 2. But they are not connected in any way. They are independent events. Sometimes we have things that are independent. Let me go to the next slide. Hopefully this makes sense. Sampling with or without replacement. Again, that's what the title says. And it's hard to get everything into the screen. And my face is just always in the way, isn't it? I'll put it up there by the title. Sampling with or without replacement. Let's say that there's a jar of cookies and it has chocolate chip and oatmeal, 2 chocolate chip and 3 oatmeal. So as I reach in to grab one, the probability of getting a chocolate chip is 1 out of the 5. 2 out of the 5, sorry. There's 2 choices there out of the 5. And the probability of getting an oatmeal is 3 out of 5. So that's a probability of just getting 1. But what if I want 2 cookies? So the probability of me getting a chocolate chip, eating it, and not replacing it, and then going in and getting another cookie, that changes my odds. I now only have 4 cookies. 1 is a chocolate chip and 3 are oatmeal raisin. And so therefore, higher probability of me picking one of the oatmeal ones. So that's what with or without replacement is. Once I take that choice out, it does change the odds of what is left. So if it is not known whether A or B are independent or dependent, we assume that they are dependent unless we can show otherwise. When we're taking the cookies out, those are dependent events. It depends on what kind I pulled out the first time to what odds are left in that jar. So that's an example of a dependent event. If A and B are mutually exclusive, they cannot occur at the same time. We already mentioned that. So this means that A and B do not share any outcomes. And so when we talk about A happening and B happening, that probability has to be 0. So we write that as probability of A and B happening. Well, that's going to be 0 because they cannot happen together, right? I cannot be left-handed and right-handed. So the probability of me being right-handed and the probability of me being left-handed is 0. That is not going to happen. And there's some numbers using some sample spaces of number sets. That might be helpful to you. I'm going to just see if I can slide that over so that will be on the screen if you want to look at that a little bit. So that is the AND on mutually exclusive events. Sometimes we have that probability is going to be 0. And it walks through what is not mutually exclusive. And I think this is a pretty good exercise to help explain those words. So if you want to pause and read that, that would be great. And that's our last slide. Okay, good luck. It was a short one, but some important points about independent and mutually exclusive events.